All right, hello, Michael. This is 5-6 notes for geometry. I'm going to write at the top of this page kind of what this concept is about, or what 5-6 is about. We're talking about inequalities. Shh. We're talking about inequalities. The main topic here is something called the hinge theorem. Okay, it is represented in this box. We have the hinge theorem, and then we have the converse of the hinge theorem, which is like the opposite. Okay, so the hinge theorem and then the opposite of the hinge theorem. So here's what the hinge theorem says. Okay, I'm going to explain this to you in like layman's terms just so that you understand like how this works. Okay, so the hinge theorem. Let's say that I'm comparing two different things. And for now, let's say that we're talking about the girls' bathroom and the boys' bathroom. Okay, and what we're doing is we are comparing like the doorways and how open the door is, right? Like we're opening the door of the girls' bathroom, opening the door of the boys' bathroom, okay? Now let's say the girls' bathroom, the doorway is 32 inches, and same thing with the boys' bathroom. They are both the same width. 32 inches is how wide like the door frame is, right? The doorway is going to be a little bit smaller than that, like the actual door itself that opens and shuts, right? So let's say that this is the door, and the door is actually 30 inches, right? So like from frame, like from one side of the frame to the other is 32 inches, but the door itself is 30 inches, right? Okay, let's say the same thing's happening here. I'm going to make this not open quite as wide, but let's say that this is also 30 inches. This is a 30-inch door. So everything is the same. The boys' bathroom door, frame, and door are the same as the girls' bathroom door, frame, and door, right? Like this has to be true. This is what the hinge theorem says. Ready? Let's say the girls' bathroom door is open, let's say 55 degrees, right? Like it's open 55 degrees. Let's say the boys' bathroom door is only open like 30 degrees, right? Like from there to there, okay? If I run a string from the handle of the door to the entryway of the door and run a string from here to here, they're talking about the hinge theorem, right? Which opening will be wider? The girls' bathroom door, right? Because if I look at the angle opposite that hinged open, this one is hinged open wider. Right? Like that only makes sense. Okay, now here's what needs to take place though. Okay, so let's say the boys' bathroom, we're comparing that, and we are now instead comparing something that is like 60 inches versus the doorway would be like 58 inches, right? And let's say that this is only 25 degrees, right? And now we are comparing this to this. This is open 30 degrees. This one's only opening 25 degrees. But is this one necessarily bigger than this one? No, because we're talking about different sizes of doors and frames, right? So what needs to happen first and foremost before we can compare the two is that the doorway has to be the same as this doorway and the frame has to be the same as the frame, right? Like we have to be comparing two things that are equal, then we can look at the angles, right? If we're looking at these two in comparison, this opening may be wider than this one, even though it's 25 degrees and the other one's 30, right? Like they have to be equal in all other aspects besides the angle, yeah? This is what the hinge theorem says. And now why is it called a hinge theorem? Because it's like hinging open at that angle, right? Okay, so let's go down to this diagram. This is what the hinge theorem says. Here is my door frame right here, and it's the same as this door frame, okay? And this is my door that's in pink, like the door is swinging open. This is swinging open at 43 degrees, and this one's swinging open at 30 degrees, okay? So what we're comparing is BC in comparison to GH. What is BC in comparison to GH? BC is going to be bigger because 43 is bigger, so that makes BC bigger. And GH is 30 degrees. So I'm going to put a greater than symbol right there. Does that make sense? Okay, that is what the hinge theorem says. We're just comparing that opposite side, the side that's opposite the angle. Okay, now this one is the converse of the hinge theorem, which is the opposite. Converse or opposite of the hinge theorem. Okay, and here's what it says. Here is my door frame. It's the same as the door frame here. The door, I'm going to make my door in pink. So here's my pink door, and here is my pink door open really wide, right? There's my door swinging open, okay? So I have 8, which is right here, and I'm comparing that to 12. And that allows me to compare the angles. Okay, so if this is 8 and this is 12, which two angles are we comparing?
R, or Q, R, P, and K, L.
Yeah, like I'm just going to compare L and R. I can just call them L and R because there's only one L and one R. So I'm looking at like this guy in comparison to this guy. He's opposite that side. So if I talk about angle L versus angle R, which one is bigger? R is bigger. So I'm going to do this symbol right here, right? Do you see why R is bigger? Like my door is swung way far open on R, making R a bigger hinge open than what L was. L was only open 8. This was open 12, right? It's kind of like the mouth of the shark. Like this guy's shark mouth is way extended. This guy's shark mouth is not terribly extended. Got it? Like you're looking at the angle. Got it? Okay, that is the converse because they're giving us the side and we look at the angle, right? All right, let's go down and look at some stuff here. So, first thing that we need to do when we're comparing, we need to make sure we have a door and we need to make sure we have a frame. So, this one, I have like a door frame right here. I have the frame. And do I have another side that has to be the same for those two triangles? Which one? XZ because of the reflexive property, where those two are the same. Now that I have a door, this is the same as this, and this door is the same as this door right here. Now I can compare the angles, okay? So this is 51 degrees, this is 55 degrees, and I'm comparing WX and XY. So which one is bigger, WX or XY? XY is big, and this guy is smaller than that, so I'm going to put my inequality symbol just to go like that. I'm not going to rewrite anything. Do you guys see how I get away with doing that? Okay, that guy's bigger. Does that make sense? Okay. All right, let's go to this other one. Do I have two sides that are matching two sides? So like my door and my frame and my door and my frame. I know that this guy is the same as this guy. What else is the same?
The middle. CF.
The middle one, FC, because of the reflexive property. So if I was doing this as a proof, I would need the reflexive property. All right, now I can use 3.6 and 3. 3.6 tells me which angle are we looking at? F. I'm comparing F to C. Okay, which one's bigger, F or C? F. Okay, they name them with 3 letters. Here is C, here is F, because that's a middle letter. So F you said was bigger. This guy is smaller, so I need to put my symbol this way. If I don't want to have to rewrite, I can just put it that way, yeah? Does that make sense? 3.6 is bigger than 3, so I'm comparing F to C. F is bigger than C. Got it? Like, this is not that hard. It's just hinging open, right? Okay? What is your question?
Tomorrow during second period, can me and Kelsey come in and interview you?
No.
About this daycare thing. And we have to videotape you.
For what? Why? Am I going to be on something?
Huh?
Where is this posted?
We got in charge of making a video for the community grant for the new daycare.
And who's going to see this video?
The community. So, we need your... But you have a good opinion because you have to skip school days because your kids are sick.
Can I see what questions, you're going to ask me ahead of time so I can, like, formulate my... Sure.
I'll email them to you.
Okay.
Okay.
Mrs.
Tomorrow's
Fagan.
second period.
Mrs. Fagan.
Okay. All right. Okay, example 2. I really like this question because there's like kind of a trick to it. Okay? 2 paintball teams are leaving the same base camp. I'm going to say base camp is here. This is the base. Base camp. Okay? Team A is going 7.5 miles west. Okay? So let's just say for all intents and purposes that this is north, right? As it sits in this room, north is actually that way, right? But if we say the top of the paper is north, which way is west?
To the left.
To the left. This is west, okay? And this is where Team A is going, and they are going that direction for 7.5 miles, okay? All right, then what's happening is they are going to change direction, and they are going 35 degrees north of west. So they start to go like this, right? And now here's the deal. 35 degrees north of west. If they would have continued going west, it would have looked like that dotted line. But now they're going north of west, which is 35 degrees here, right? Like that, okay? How far are they going 35 degrees north of west? 35 degrees north of west and go 5 miles. So they're going 5 miles in that direction. Does that make sense?
Yeah, about that far.
Okay, about that far. All right. Group B is starting at base camp, and they are going how much? 7.5 miles east. So they're going the exact opposite direction. They're going 7.5 miles that way. And then they turn 40 degrees north of east. So if they would have continued going east, it would look like that. But they're going 40 degrees north of that. So this is 40 degrees. Do you see that? And how long are they going for that? 40 degrees north of east for 5 miles. So they're doing exactly the same. They're going the same distance as what the first one was, right? 7.5 this way and 5 this way. 7.5 this way and 5 this way. Got it? So our door and our frame and our door and our frame are all the same. Got it? Whoa. Go back. Okay? Now they're saying at this point. So this is where Team A is. Team A is right here. This is where Team B is. Team B is right here. They want to know, if I go back to the base camp, which one is farther?
B. Has to be. They're 40 degrees.
No, it has to be A because
No, because
no, 35
it's the
because
opposite angle.
I'm farther right here than I am right here.
it would be A because it has
Okay, so you people who said B,
It's A because it's the.
you people who said B are comparing 40 to 35, and you said 40 is bigger, right?
Wait, no, it is A. It is A.
But the problem is,
It's A.
we want to look at this angle right here. So if this is 35, what's this angle right here? If this is 35, what's this angle? 145. This is 145 degrees. Is the hinge, right? Okay, that's how open it is. What is this angle if this one's 40? 140. So we don't want to compare 35 and 40. I want to compare 145 and 40. Now which one's farther?
A.
This one. The farther one is A. That was tricky, right? Did you get tricked?
No.
Okay, you're not wanting to look at the 35 and the 40 angle. You want to look at the one inside of the triangle. Got it? Does that make sense? That would be a thing. So A is farther because 145 is the degree for that one. Yeah? Don't let that trick you. Okay, example 3. We are on example 3 solving for X, and they want a range of values. Okay, here we go. Example 3. We're solving for X, and they want a range of values for X. So what X can be and cannot be. So we're comparing this triangle to this one. Got it? All right, I know that this side matches this one, but I have to have two sides match. What other side matches? EH, the one that they share, right? The reflexive property. All right, I know that this is 65 degrees, and I know that this is like that 6x plus 15, okay? If I'm looking at 6x plus 15 in comparison to 65, what does it have to be? 6x plus 15. Is it equal to 65?
No.
Yeah.
Look at the 11 and the 9.
Bigger. It has to be bigger.
Okay, Josie says 6x plus 15 has to be